Hello and welcome to High Voltage Engineering. Today we're talking about conduction and breakdown of liquid dielectrics. In this class, we'll be talking about the characteristic of liquid dielectrics. There are basically three different characteristics we'll be talking about: the electrical properties, its heat transfer characteristic, and its chemical stability. Okay, so we'll start our session. So essentially, a liquid dielectric should possess good dielectric properties, excellent heat transfer characteristic, and must be chemically stable. So these are the three things that must be there for a liquid dielectric. So a good dielectric property, that means they show good insulating properties. It should have a good heat transfer capabilities, and obviously it should be chemically stable because it should be resistance to all the environmental effect on it. So it should be chemically stable under a range of condition under which the equipment operates. So we'll be talking about three different properties. We'll be talking about the electrical properties, the heat transfer characteristics, and the chemical stability. Okay. The first property is the electrical property. The electrical properties that are essential in determining the dielectric performance of liquid dielectrics are its capacitance per unit volume or its relative permittivity, its resistivity, loss tangent, that is tan delta, or its power factor, which is an indication of power loss under AC voltage application, and its ability to withstand high electric stresses. So these are the four parameters that measures the electrical property that requires to determine whether the dielectric is good or bad. That is whether about that is the measure of its capacitance per unit volume, or basically its relative permittivity, its resistivity, that how much resistance it creates, the loss tangent, or the actually it is the power factor that indicates the power loss for the AC transmission, and its ability to withstand high dielectric stresses. Permittivities of the most of the petroleum oil vary from 2 to 2.6, while those in the silicon oils vary from 2 to 73. In case of non-polar liquids, the permittivity is independent of frequency, but in case of polar liquids such as water, it changes with frequency. For example, the permittivity of water is 78 at 50 Hz and reduces to 5 at 1 MHz. Resistivities of the insulating liquids used in high voltage application should be more than 10 to the power 16 ohm meter, and most of the liquids in the pure state exhibit this property. Power factor of a liquid dielectric under AC voltage will determine its performance under load condition. Power factor is a measure of power loss and is an important parameter in the cable and capacitor system. However, in the case of transformer, the dielectric loss in oil is negligible when compared to copper and iron losses. Pure and dry transformer oil will have a very low power factor varying from 10 to the power minus 4 at 20 degrees centigrade to 10 to the power minus 3 at 90 degrees centigrade at a frequency of 50 Hz. Dielectric strength is the most important parameter in the choice of a given liquid dielectric for a given application. The dielectric strength depends on the atomic and molecular properties of the liquid itself. However, under practical conditions, the dielectric strength depends on the material of the electrodes, temperature, type of the applied voltage, gas content in the liquid, etc., which change which change the dielectric strength by changing the molecular properties of the liquid. The above factors which control the breakdown strength and leads to the electrical breakdown of the liquid dielectrics. Now we'll talk about the heat transfer characteristics. We talk about the heat transfer characteristics in equipments filled with liquid dielectric, that are transformers, cable, circuit breaker, etc. The heat is transferred mainly by convection. Under natural atmospheric cooling condition, the convection that is given by N is equal to a function of K cube AC by nu to the power N, where K is the thermal conductivity, A is the coefficient of expansion, C is the specific heat per unit volume, and nu is the kinetic viscosity. This is the nu is basically kinetic viscosity, and N can be taken a bit value between 0.25 to 0.33. The main factors that control the transfer are thermal conductivity, that is K, and viscosity nu. It can be seen that a higher value of K is preferable for apparatus likely to operate continuously at high temperatures. On the other hand, a low value of K and high viscosity can lead to a localized overheating and or even electrical burnout. Silicon oils do not exhibit these properties and therefore pose severe overheating problems in the equipment that use these oils. Now we'll go to the chemical stability. So we are talking about liquids as insulators, and one of the characteristics of liquid dielectric is its chemical stability. In service, the insulating liquids are subjected to thermal and electrical stresses in the presence of material like oxygen, water, fibers, and decomposition products of solid insulation. These either singly or in combination change the degradation of the liquid, with the result that soluble solids and gaseous products are found, which can result in corrosion, impairment of heat transfer, deterioration of electrical properties, increase in dielectric losses, discharge, and arcing. In the absence of any remedial action, this cycle continues and produces even ever worsening liquid purity and equipment condition. So these are the different characteristics of a liquid dielectric. So this is the end of this lecture. Thank you.